All right, so in this video, we're just going to continue these notes 10.3 on confidence intervals where we have two samples instead of one sample, okay? And in this note packet, we left off where I gave you a flow chart that tells you which Minitab to use based on the question that you're given, okay? So let's just take a look at this chart. I told you that next week on the exam, you're going to be given a problem. It's going to be a big paragraph and it's going to ask you a question, okay? And based on that question, the hardest part of that question is honestly determining which test on Minitab to use. So I said, first of all, you're going to decide if you're given one sample or two samples. I think that's pretty easy just by reading the question. If you're given just one sample, the next thing you need to do is to decide if your assumptions are met. So your sample's big enough or the population's normal. After you know that you can do the problem, you decide, okay, look at the standard deviation. If you're given the population standard deviation, use the one sample z-test. If you're given the sample standard deviation, use the one sample t-test. So that's pretty easy. Now, if the question gives you two samples, the next thing you need to decide is if you're given independent or if you're given paired samples, okay? If you have independent samples, well, you have to decide, okay, can I do the question by seeing if your assumptions are met? And if that's true, use the two sample t-test. If you're given paired tests, well, easiest question on Minitab, use the paired t-test. Why don't we put this into practice, do a few problems, and, well, see if we can tell which question to use. The first question talks about a geologist. He's claiming that the mean weight of a type of boulder is 70 pounds. They took a sample of 50 boulders. The mean was 72. The standard deviation was 2. We want to know the mean weight of boulders is less than 70 pounds. Okay, by reading this question, it definitely seems like we only have one sample, right? We only have one set of information. Looks like we have one sample. Since all the problems that I've given you seem to fit the assumptions right now, let's not focus on if like the assumptions are met. Let's just go on and see which test we would use here, okay? We have to determine if we're given the population or sample standard deviation. So let's take a look here. Reading through the question, I don't actually care about the mean or the sample size. All I really care about here is the standard deviation, right? So here the standard deviation is 2. Okay, now this is actually the sample standard deviation, mainly because, well, the standard deviation is mentioned in the same sentence as where the sample is introduced. Let's take a look at our flowchart and see what we do. Remember, if we're given the sample standard deviation with one sample, looks like we're using the t-test. So that's why number 1 is the one sample t-test. Just by looking at this question, we definitely have two samples, right? We literally have fertilizer A and fertilizer B. That looks like, well, we're given two samples. And if you read through the question, it will tell you that, yeah, we do have two samples, but let's just take a look and see if there's any hints if it tells us if we have independent versus paired samples. Let's just pretend that maybe we thought that these samples were paired, okay? If we have paired sampling, you can pair each observation in sample 1 with another observation in sample 2. So I could pair together these two, and 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 whoop, once I'm here, there's nothing to pair it with. If each of your samples have different sample sizes, that's a big hint that these are not paired samples, okay? So, well, the only other option for us to have is independent samples. Okay, so if ever you have two different sample sizes, they can't be paired. It has to be independent sampling. Now, I actually didn't go ahead and read the question, so let's just go ahead and read what's going on here. I think there's actually a typo here because it said that 16 randomly selected plots of land were treated with fertilizer A. It looks like there's only 5 things in fertilizer A. So let's just change that to 5. And fertilizer B has 1, 2, 3, 4, 5, 6, 7. Let's just change that to 7. Okay. Now it says that 5 randomly selected plots of land were treated in fertilizer A and 7 different plots were treated with fertilizer B. So because there's no relationship with the plots of land that were treated with fertilizer A and the plots of land that were treated with fertilizer B, Well, since there's no relationship between the two, that's another big hint that we have independent samples, okay? So because of the sample sizes and also since there's no relationship between the two, I would definitely say that this is independent sampling. And taking a look at our flow chart, well, we said that independent samples get treated with the two sample t-test. So this is definitely the two sample t-test. Now, in this example, we have a group of 8 individuals with high cholesterol levels. They're given a new drug to lower cholesterol levels. We have their measurements before and after. And I guess looking at the question, it seems like it's the same individuals. They're just being tested before and after. Okay, so we definitely have two samples because we have a before sample, we have an after sample. And taking a look at the data, it looks like both the sample sizes are the same. So that's a good hint that we might be thinking about paired samples. Now, that's not saying that independent samples can have the same sample sizes. That does happen a lot. So let's just go a little further to see maybe why this might be paired and not independent. Well, looking at the data, it kind of seems like, well, the first column might represent the first person, and the second column might represent the second person, the third column, the third person, and the fourth column, the fourth person. Now, I can definitely see a relationship between the before and after, right? It seems like maybe the first two observations in each of the samples can be paired together. Same with the second and the third and the fourth. So that's a good hint to me that this is paired. Another reason why I'm thinking that this is paired sampling is, well, I'm pretty sure the person's before cholesterol levels might have an effect or some sort of relationship with their after cholesterol levels. For example, if someone has like high cholesterol before, I would still expect their after to be a little bit higher. So I would think that there's some sort of relationship between the two. I'm thinking paired for this one. Okay, so since we have paired sampling, let's take a look and see what Minitab test we're using. Well, under paired sampling, we use the paired t-test. So that's what I'm using here, paired t-test. Let's go on to number 4. Here we're talking about the National Health Statistics reports, looking at a sample of 361-year-old baby boys. We have the mean weight being 25.5 pounds. We know the population standard deviation is 5.3 pounds. Then we're doing a hypothesis test where we think that the weight might be greater. Definitely only has one sample. Looking at our flow chart, if we have one sample, we have to decide if we're given the population standard deviation or the sample standard deviation. So all we care about here is the standard deviation. Let's see which one we're given. Standard deviation is 5.3 pounds. It literally tells us in the question that this is the population standard deviation. So since it says population standard deviation, let's take a look at the flow chart. Population standard deviation looks like we're using the one sample z-test. Moving on to number 5, we're looking at a survey of adults with diabetes. We're looking at the average BMI in a sample of 1924 women. We have a mean and a standard deviation. Next, we have the BMI of a sample of a different number of men, mean 30.4, standard deviation 0.5. We're doing a confidence interval question here. So looking at this question, we're definitely given two samples here, right? We have women and we have men. Those are the two samples that we're given. Let's take a look at the chart. If we have two samples, we need to decide if we're doing independent or paired samples. So let's just take a look and see what we have here. Well, if the first sample is a bunch of women and the second sample is a bunch of men, I don't think there can be any way we can relate them to each other, right? Also, I don't think there's much of a relationship between the observations in sample 1 and the observations in sample 2. The people in sample 1 are a completely different set of people than the people in sample 2. Another hint that this is giving me that this is independent sampling and not paired sampling is look at the sample sizes. We have 1924 people in the first sample and 1559 people in the second sample. Whenever you have paired sampling, the sample sizes always have to be the same. So if the sample sizes are different, that's our big hint that this is independent sampling and not paired sampling. So this is definitely independent sampling. Let's see which Minitab test we have to use here. It says if we have independent samples, looks like we're using the two-sample t-test. So the answer for number 5 is two-sample t-test.